everyone, we're here to go over some content from Eureka Grade 5, Module 3, Lessons 5 and 6, or specifically about subtracting fractions with unlike units. So we're going to look at two problems today. The first one is 1/2 take away 2/5. Just like when I add my fractions, I have to have the same unit. If I have 36 take away 18, I'm not going to do my 6 take away 1 because my 6 is in my 1's place and my 1 is in my 10's place. So let's talk about how we can rename these as equivalent fractions with the same unit. So I've represented my two fractions on my area model. I have my 1/2 and my 2/5. I have put in my subtraction sign just to remind myself that I'm not combining, I'm subtracting. I'm going to go ahead and find my equivalent fractions just like I would anytime I have my area model. So I see that I'm going to go ahead and show my fifths, and I'm going to go ahead and show my halves to find that equivalent fractional unit of tenths. So I'm splitting my 1/2, each of my halves into fifths. My identity property tells me that I can multiply by a version of 1, in this case 5/5, and I still get my same value. It's just in a different representation. And I would get that equivalent fraction of 5/10. 1/10, 2/10, 3/10, 4/10, 5/10. For my 2/5, I split each of my fifths into halves. 2 halves is equivalent to 1 whole. So I'm not changing my value, just my representation, to get that equivalent fraction of 4/10. So I can rewrite my expression. 1/2 is the same as 5/10. 2/5 is the same as 4/10. 5/10 take away 4/10, so take away 1, 2, 3, 4, leaves me with that 1/10. 5 take away 4 is 1, and my unit is tenths. Moving to one that starts with a total that is greater than 1, I have 1 1/2 take away 2/3. So I've shown my 1 1/2, and I've also reminded myself that 1 1/2 is the same as 3 halves, because I have 1 whole, which is the same as these 2 halves, and then 1 more for a total of 3 halves. So here's my 3 halves, and I'm taking away that 2/3. I'm going to go ahead and mirror the lines on each of them, so that way I can find an equivalent unit. So I'm going to show my thirds on my halves, and I'm going to represent my halves on my thirds. And I can see that I've now got an equivalent unit of 6. With my 3 halves, I cut each of my halves into thirds. I'm multiplying by 1, because 3/3 is the same as 1, so my value is not changing. So I get 9/6, 6/6, 7/6, 8/6, 9/6. And then for 2/3, I cut each one into halves. So now I have 4/6. All right, so I can go ahead and rewrite this. 1 1/2 is the same as 9/6. 2/3 is the same as 4/6. 9 take away 4 would give me 5, and my unit is 6. All right, friends, I hope that this was helpful, and as always, please let me know if there's anything I can do to help. Thanks so much.